Hey, Philosophy and Bim here. In this video, I'm going to be talking about reference plane and parameter. When it comes to creating parametric family, you're going to need to know how to use them and understand the purpose of them. Okay, let's get started. I'm in a generic template in the reference level, which is floor plan. By default, you have two reference planes already, and they are left and right, center, and front and back. To create another reference plane, you can go to Create tab. There's reference plane. There's also reference line. I'll be skipping reference line in this video and only focusing on reference plane for now. Once you click on the reference plane, I can go from left to right and draw a new reference plane, just like that. When I select the reference plane, under the properties here, there is a parameter called name. You can give it a name there, or you can also give it a name when you select the reference plane, just like this. I'm gonna go ahead and give it a name. Like this. When you name a reference plane, it will become a work plane in the family. To better illustrate the idea, I'm going to go to the 3D view. I'm going to go to visibility graphic first. I can go to the properties here, go to visibility graphics, or I can type the hotkey VV. I'm going to go turn on the level in the 3D view first. This will help me illustrate the idea of what a work plane is. And in this 3D view, by default, the reference level is going to be the current work plane. You can change the work plane in the 3D view or any other view for that matter. All you need to do is to go to Create tab, go to Set Work Plane here. From the drop down, it shows that the reference level is the current work plane. I could change it to say front and back, or left and right, or the name work plane that I created. Say if I go to front and back, you'll see right now the work plane is now changed to this direction. You can also click on this show button to tell Revit what's the current work plane is in your view. So you can see that again, this vertical plane is now your current work plane. So if I go ahead and say change to left and right and hit OK, you'll see now the work plane shifted. Or I could choose the one that I created with a name on it. So as you can see, that is now there. So let's go ahead and change it back to the reference level. So say if I use the Create tab and create a extrusion in the 3D view. So let's go ahead and just create a box over here and just go ahead and finish. So you can see the work, you can see the solid geometry here. The extrusion is now associating with the reference level on the ground plane. Now let's go ahead and switch that work plane to front and back. And if I were to create an extrusion again in the 3D view, like that. This time you can see that geometry is hovering from that work plane there. Let's do 2 more. If I change it to the left and right, and you'll see now, if I were to create an extrusion, this extrusion now, again, will be associated with this work plane. And of course, let's do 1 more on the work plane that I created. So now if I go to create extrusion again, let's go ahead and make a circle this time, like that. Okay. So you can see now I have 4 extrusion, but all these extrusion are now referencing to different work plane. I can select this geometry here, and it'll tell you my work plane is this reference plane that I name it, that I created. Okay, so let's take another look here. In plan view, you can see that each box or geometry associating with different work plane. This is the one that I created. So what happens is, let's go ahead and do a tile view. And let's go ahead and turn off this show work plane. So if I were to move this work plane like so, you'll see my geometry move together. Because pretty much this extrusion is now stick to this work plane. So that means that whenever I moved it, it moved with it. So think about anything that you are going to be creating in Revit. Your geometry should always be associating with some sort of work plane, whether or not it's in the ground level like this or in the vertical plane like these. There's always a work plane this geometry should be stick to. Okay. Alright, so let's go ahead and delete all these geometries here. And so say if I create another reference plane over here. If I don't give a name to identify the work plane, let's go to the 3D view. Go to set work plane. You can see only the name work plane we'll be able to use as a work plane. So such as reference level, front and back, left, right, and the work plane that I created. For the one that without the name, you won't be able to choose it to use it. So remember that. Okay, so now I want to talk about how to create parameters. So in this case, I'm going to create 2 more reference plane like this. And let me go ahead, change it to tab view. Now that I have a grid of reference planes, I can go to the annotate tab or simply go to my quick access bar and use the dimension command to create a series of dimension like so. Anytime you have a dimension associated with your reference plane, you can turn this dimension and go to the create parameter label and create as a parameter. I'm about to name a parameter here. If you are creating content for your company, chances are there are naming standard that you should be following, whether it's all caps or all lowercase or title case. In this case, I'm going to be using title case and give it a name called width. I'll be doing the same over here. Go to create parameter and I'll give it a name for depth. I'll leave everything the way it is as a type parameter, as dimensions, and hit OK. Now that I have two set of parameters created, these becomes basically the backbone or the framework of your parametric family or for your geometries. So what I mean by that is, now that these two parameters, I can access it over here, which is under family types. So when I select this icon, the depth and the width parameter will get populated here. So what I'm about to do is to call flexing. Usually what I like to do is to give a lower number or the higher number of the value of the parameter. So in this case, I'll give it like 3 feet here and see if my reference plane and my dimension going to be acting together. So you can see that now it changed to 3 feet. Then I'm gonna give a higher number. I'm gonna give it 7 feet and then it flex it back. So this is to tell me that this is working. Normally, I'll highly recommend to flex your parameter for the one that you created. In this case, go ahead and flex the width as well. So I'll give it a, again, lower value first, like 2 feet. And then a higher number, like 6 feet. As you can see that, they're all working. So what I'm gonna do, I'm gonna go ahead and keep them at 5 feet both in both directions and hit OK to exit it. So now if I were to create a geometry like an extrusion, for example, go to create tab, extrusion. In the sketch mode, there are a couple of ways you can go about creating the extrusion that is going to be parametric geometry. So you can use the rectangular line tool, or you can use just linear line or use pick line. My preference is actually using pick line. I'll go ahead and pick this reference plane here. When I see the lock there, I'll go ahead and lock it immediately, like this. If I forgot to lock it, like this, oops, okay, let's go back. If I forgot to lock this line is not going to associate with the reference plane. So there are a couple of ways you can go about fixing it. You can either use align and lock. So in this case, I'll probably just move it away like this, and I'll use the align command, select the reference plane and then the line and then lock, like so. Of course, I have to use the trim to clean up these overlapping lines before I can finish my sketch. And I'm gonna go ahead and finish it. Let's go ahead and change it to the shaded mode and also 3D view, like that. So basically, now I just created a parametric extrusion. Let's go ahead and flex it and see what happens. So let's go ahead and go to family types. And let's flex the depth and width one by one. Again, using the smaller and a higher number. I'm typing 3 feet. That works. And 6. That also works too. I'm gonna put it back to 5. Same thing here. That works pretty well. So you see there's nothing controlling the height of the extrusion. Well, of course, we haven't done anything to it yet. So in this case, let's go ahead and go to front elevation. Like so. Let's go ahead and create a new reference plane. And put a dimension here. When it comes to placing a dimension in the front elevation, you need to be sure that your dimension is tied to the reference level, which is the level datum. Because there are two objects here. I'll show you. There's a level, there's a reference plane. So behind it, there is another reference plane right there. So when it comes to placing a dimension, make sure that your dimension associates with the reference level, which is the datum, then to this reference plane, like so. So now I'll go ahead and turn this dimension into another parameter called height. Hit OK. Let's change it to the shape view. You notice that my extrusion is still kind of down here. So to make sure that the height associated with the parameter and the extrusion, I would use align. Simply use align, select a reference plane, and then the face of the extrusion. When this locks show up, go ahead and lock it, just like that. So now if I go back to 3D view, the height parameter is also now listed under the family types window. So in that case, if I flex it this time, again using a smaller value or higher value, the height should already corresponding to the number that you punch in. As you can see that they are all flexing correctly, just like that. So there you have it. So this is like a parametric object now that has the X and the Y and the Z properties that are all listed here under the family types. Okay, with that, that's all I have for this video. I hope you like it. If you do, give me a like or subscribe to my video. I'll see you next time. Bye.